What's up? I'm Vin, and today I want to show how to use the law of cosines in the case of side, side, side. And that's when we're looking to find one of the missing angles. So here's the formula that we're going to need, and let's get started. So for this question, we have a diagram of triangle PQR, and we want to find the measure of angle P, which is this angle over here. Now, one of the most common things I see students struggle with questions like this is setting up the formula correctly. Because as we saw on the last page, what we had was we had a squared plus b squared minus 2ab cosine of angle C is equal to c squared. And the way I recognize this formula is that the left side, the messy side, I look for the side angle side connection. And what I mean by that is we have side A, side B, and we have angle C. And notice that's what's making up the left side of the equation. So what we have here is this side, 10 units long, would refer to side R. So I'd put a lowercase r here. 12 would represent side Q, so side Q is 12 units long, and then side P is 15 units long, like this. So when I say I'm looking for a side angle side connection, if I'm trying to find the measure of angle P, you could see the side angle side that builds angle P here. Well, the two sides that build angle P are side R and side Q. So when I'm setting up the law of cosines for this triangle, we're going to have r squared plus q squared, and this is side r squared plus side q squared minus 2 times side r times side q times cosine of angle P, which is the angle between them, is equal to side P squared, like this. Because now that we have this formula set up, finding the measure of angle P is going to be very direct. Now from this stage on here, there's a few ways we could do this, but what we could do now is just plug in. So we have r squared, so we're going to have 10 squared plus q squared, we're going to write 12 squared, minus 2 times r is 10 units, q is 12 units, and then we have cosine of angle P, and that's what we're trying to find, the measure of angle P, equals side P is, we're going to write 15 squared, like this. So now we just have to do a little bit of algebra here. Well, this, we're going to have to combine 100 plus 144. That's these two squared. So 100 plus 144 is 244. And then we have minus 2 times 10 is 20 times 12 is going to give us 240 cosine of P. Now, another mistake here I see, and first we'll just square this. 15 squared is 225. But another mistake I see is that students try to do 244 minus 240 is 4, and then they write cosine P. But notice these are not like terms. This is a constant, and this has a cosine attached, so we have to leave them separate. So next up here, we're going to subtract 244 on both sides. And our goal is to isolate the cosine P term. So we have minus 244 on the left and right. And now this is going to cancel out, and we have minus 240 cosine of angle P equals, and if we subtract these two, 225 minus 244 is negative 19. And now just divide both sides by negative 240, and we're almost at the final answer here. So this brings us to this step. And now we have cosine of angle P equals, and now a negative over negative goes positive. So this is going to be 19 over 240. And now to solve for the measure of angle P, we have to do the opposite of cosine. And the opposite of cosine is cosine inverse. So the measure of angle P is equal to cosine inverse of 19 over 240. And now the rest is all calculator work. So once again, we have cosine inverse of 19 over 240. And I didn't say what to round to in this question. Let's say we're going to round to the nearest hundredth. So our answer would be 85.46 degrees. So once again, rounding to the nearest hundredth, we have 85.46 degrees. And that's the measure of angle P. Now, one last thing I want to mention here is that I've had students in the past that prefer this style of solving. What they prefer to do is solve for angle P first in terms of all these variables, and then they just plug everything in. So if you do minus r squared minus q squared on both sides, we could start to, and let's make that a little neater, so minus r squared minus q squared. What we could start to do is isolate this cosine P term. So we have negative 2rq cosine of angle P equals, and we have p squared minus r squared minus q squared. Now from here, we could divide both sides by negative 2rq, and that's going to get us to this step here where we have cosine of angle P is equal to this. So now if we want to find the measure of angle P, how do we get cosine to cancel out? We could do the cosine inverse of both sides, and that's going to get cosine to cancel, and we'll have cosine inverse of p squared minus r squared minus q squared over negative 2rq. And the benefit of doing the question this way is now we could just plug in the value of p, q, and r right into this expression, and it's going to tell us the measure of angle P all in one shot. So let's try that method out. So we have cosine inverse, and what we have is we're going to write in a fraction here. We have the fraction, and I wrote alpha y equals enter to pull up a fraction. So we have p squared, which is going to give us 15 squared. And then we have minus r squared, and r squared is going to give us 10 squared like this. And then we have minus q squared is, we're going to replace with 12 squared like that. And we were dividing by negative 2 times r times q. So r once again is 10, and q was equal to 12 units. So watch what happens here. If we exit that and close the parentheses and press enter, notice we get the exact same answer. So it depends on your style. If you prefer option 1, go with option 1, or you could go with the second option here.